Hello students, welcome back to the JEE Last Mile Preparation Series 11. Today we will take up questions 21 and 22. But before I do that, by now you already know that I'm Sujata from CBSE NEET JEEchemistry.in, and we are bringing you two questions every day until April 4th to help students get that extra edge for their JEE chemistry exam preparation. To keep me motivated in this task, please hit the like button and don't forget to subscribe to my channel. Also, please visit my website. The link is in the description below. So let's get started. We continue with physical chemistry. The two questions today are chosen from redox and electrochemistry. So here is question number 21. This involves a redox titration question. Let's get familiar with the question. A 20 milliliter solution of hydrogen peroxide containing 0.2 grams of impure hydrogen peroxide completely reacts with 0.316 gram of potassium permanganate in acidic solution. The purity of hydrogen peroxide is this percent. So this is a numerical value type question where you have to determine or calculate the percentage purity of hydrogen peroxide in this given 20 milliliter solution. You're provided with the molecular weights of hydrogen peroxide and KMnO4. So that will simplify your calculations. Okay. Now let's get started. Let's look into the question. Okay. What is the role played by potassium permanganate in acidic solution? You're aware of that. It plays the role of an oxidizing agent, which means potassium permanganate gets reduced. Hydrogen peroxide undergoes oxidation. Now, this question is very helpful because this will also give you an added practice to balance ionic equations and get the resultant redox equation. And that is the reason why this question has been chosen. All right, so let's see. So first, let's write down the oxidation half equation of hydrogen peroxide. So hydrogen peroxide is oxidized to oxygen. Let's use the ion electron method to balance this equation. There are two hydrogens on the left hand side, so we add two hydrogen ions on the right hand side. To balance the charges, we add two electrons on the right hand side. So hydrogen peroxide undergoes loss of electrons. It is getting oxidized. Let this be equation 1, and this happens to be the oxidation half equation. So we have balanced the oxidation half equation. Now let's try to balance the reduction half equation. Okay, so we know that potassium permanganate is undergoing reduction. So let's write the ionic equation. MnO4 minus is getting reduced to Mn2 plus. There are 4 oxygen atoms here, hence we add 4 molecules of water. There are 8 hydrogens on the right hand side, and hence we add 8 hydrogen ions on the left hand side. To balance the charges, what is the net charge on the left hand side? -1 plus 8, 7. On the right hand side, the net charge is 2. So difference in charge is 5. So we have to add 5 electrons to the side with higher positive charge. So this is equation 2, which is the reduction half equation. Now, in order to write the redox equation, we have to make some modifications. We have to ensure that the electrons are cancelled out. So we have to multiply the first equation by 5 and the second equation by 2 in order to cancel the number of electrons on both the half equations. So now what is the resultant redox equation? So when you multiply equation 1 by 5, we get 5H2O2, right? And on the reactant side, we also have MnO4 minus 8H plus multiplied by 2. So we get plus 2MnO4 minus plus 16H plus. Let's go back to equation 1. We've got O2 into 5, 5O2 and 10H plus. So let's write that. 5O2 plus 10H plus from the first equation, and from the second equation we have 2Mn2 plus and 8H2O. So let's write that also. 2Mn2 plus 8H2O. So now, what is the final redox equation? To get the final redox equation, you've got two like terms here and two like terms here, 16H plus and 10H plus. So the final equation is something that I'll write on the next board, and so we can do the calculations from that final deduced equation. So let's write down the equation here. 5H2O2 plus, we have 2MnO4, so that is intact. 2MnO4 minus plus, and now we will subtract. We've got 16H plus here and 10H plus here. So resultant hydrogen ions would be 6H plus 6H plus, giving you 2Mn2 plus 8H2O plus 5O2. Let's verify. Yes, 5O2 plus 2Mn2 plus and 8H2O. Okay. Now, we need to focus on these two reactants because we have been given the mass of MnO4 minus. So let's now find out the number of moles of MnO4 minus, which is mass over molar mass. And they've given us the molar mass. Mass is here and the molar mass is 158. Very easy to calculate. 158 twos are 316. So this becomes 0.002. Now what is the mole ratio between MnO4 minus and H2O2 from this equation? That is 2:5, correct? The ratio is 2:5. We know the number of moles of MnO4 minus as 0.002. So what is the number of moles of hydrogen peroxide? 0.01. 2 5s are 10. Divided by 2, which is 0.005. Correct? So now we have arrived at the number of moles of hydrogen peroxide as 0.005. Now what is the formula for the percentage of hydrogen peroxide in that impure sample, or percentage purity of hydrogen peroxide, you know, is equal to mass of pure hydrogen peroxide into 100 divided by the impure mass of the given sample. So we have the impure mass, which is 0.2 grams. So what do we have to find out now? We have to find out the mass of pure hydrogen peroxide, and that is obtained from the number of moles of hydrogen peroxide. So mass of pure hydrogen peroxide would be number of moles into molecular weight. So 0.005 into the molar mass, which is 34, and this becomes 0.17 grams. Okay, so that is the mass of 0.005, correct. So that is the mass of pure hydrogen peroxide. So what is the final step in this reaction? Percentage purity is equal to 0.17 into 100 divided by 0.2. So if you calculate this, you will get 85%. So that is the percentage purity of hydrogen peroxide in this impure sample. So it is a concept involving redox titration, and this question was definitely useful because this made you recollect how to balance the half equations, ionic half equations by the ion electron method and how to arrive at the final redox equation. So what is the final result? The percentage purity is 85%. It is a numerical value type question. Okay. Now let's move on to the next question, question number 22. So this is 0.900 volt. Question number 22. Very interesting question, and you have to think before you start solving this question. Don't be in a hurry to solve this question. Determine E naught at 25 degrees Celsius or 298 Kelvin of this reaction. Cr3 plus gaining 3 electrons to give you chromium solid. Now, what is the given data? You are given two equations, 1 and 2, wherein you have Cr3 plus aqueous as you want in the target equation, gaining 1 electron to produce Cr2 plus aqueous. You don't have Cr2 plus aqueous in the target equation. So that gives you an idea. We have to get rid of that, remove that. Now go to the second equation. We've got Cr2 plus aqueous again, which we don't need, gaining 2 electrons to give you what we need, chromium solid. So if you look at these two equations, it is evident that if you add these two equations, chromium ion Cr2 plus in aqueous medium or aqueous Cr2 plus ion gets cancelled, right? And you will get the desired target equation. So let's add the two equations, okay? Now, by the way, these are the four options. Any one of the four options would be the right answer. So let's move on to the next board and add the two equations, okay? Add equations 1 and 2. So what was equation 1? Cr3 plus aqueous plus electron giving you Cr2 plus aqueous, and you are provided with the E naught for this reduction half equation. The standard reduction potential for this half equation is found to be minus 0.424 volt. So that is minus 0.424 volt. The second equation is Cr2 plus aqueous gaining 2 electrons to give Cr solid, right? And what is the E naught value there? The standard reduction potential is minus 0.9 volt. So both these are reduction potentials corresponding to these two reduction half equations. Now let's add the two equations. When we add the two equations, Cr2 plus aqueous gets cancelled and we will arrive at the desired target equation. Cr3 plus aqueous gaining 3 electrons to give you chromium solid. Just because you added the two equations, you cannot add the two reduction potentials. Okay? You need to find out the reduction potential of this target equation. This is what you need to find out ultimately. But you cannot get this by adding these two. Okay? So what should you do? You should convert the corresponding reduction potentials to a quantity which can be added. And you have learned that E naught cell can be related to, so this is the final equation. E naught cell can be related to, or E naught reduction potential, or the cell can be related to delta G naught, the free energy change for a specific reaction. So what is the equation relating these two quantities? Which is delta G naught is equal to minus NF E naught. So we have to apply this to equation 1 and equation 2. So delta G naught 1 is equal to minus. So what is N equal to? N is equal to this 1 electron. This is your equation 1, equation 2. N is equal to 1, right? So we write minus 1 into, we will retain Faraday as F, not 96,500 coulomb, okay, into E naught. What is E naught for that half reaction, half the reduction half equation? Minus 0.424 volt, minus 0.424 volt, and that is equal to plus 0.424 424F. Okay, so many joules when E naught is in volt, and when E naught is in volt and Faraday is in coulomb, right? The charge is in coulomb. The final answer would be in joules. Delta G naught will be in terms of joules. Similarly, find out delta G naught minus what is n equal to in the second equation. N is equal, sorry, second equation, n is equal to 2, right? So we write minus 2 into f into minus 0.9. Minus 0.9 was the reduction potential, right, for the second equation. So we got that. And what is that equal to? That is equal to plus 1.8 Faraday, so many joules. Let's add up these two delta G naught. So delta G naught is equal to delta G naught 1 plus delta G naught 2. So what is delta G naught total for the final target equation? Minus NF E naught for the final equation, and that is equal to, what is the first one? The first one is 0.424F plus 1.8F. You can easily cancel the Faraday from both the sides, right? And what is n equal to in the final target equation? N is equal to 3. So we substitute n as 3. So this becomes minus 3 E naught, that is equal to, what is this now? This will be 2, 4, 8 plus 4, 12, 2.224. So what is E naught equal to? Minus 2.224 divided by 3. So that is equal to minus 0.71, and you have 1 here, so 24, maybe 3 8s are 24, correct, divided by 3, so 3 7s are 21, so sorry, 21, then you have 12, 12 is 4, 1, so many volt. Minus 0.741 volt would be the reduction potential for this half equation. This will be minus 0.741 volt. Isn't that what we got? Yes. So which option does that correspond to? Option A is the correct answer to that question. So this was a challenging question. It has to be read well, understood well, and only then you have to apply and solve the question. All right. If you found today's video useful, please like the video and don't forget to subscribe to my channel. Also, please visit my website. The link is in the description below. See you tomorrow.